properties of ROC we have completed, like for causal, non-causal, combination of two causal, combination of two non-causal.
Three causal.
Four causal.
Non-causal means it is a combination of causal plus anti-causal, isn't it? So the name given for causal plus anti-causal is non-causal, right? So let us start the next topic. As I already said, region of convergence is an important concept. Put the heading everyone, properties of Laplace transform. Properties of Laplace transform. So like in case of Fourier transform, same properties will be there. Even proof also, same steps will be there, same statements and all. First put the heading everyone. What is the first property? We are very familiar with all these definitions, property proofs and all, because we have started these properties with the Fourier series concept itself, isn't it? Linearity property. Put the heading linearity property. I think statement you can write on your own. Write down statement. See, in the exam, as I already said, properties and proofs are important for Fourier transform, whereas for Laplace transform and Z transform, properties, based on properties, we can derive signals corresponding transform pairs. I'm not saying that these are not important. Definitely, especially in the competitive exam purpose, we use these properties in deriving the transform functions as well as Laplace transform pairs for the given types of signals. So proof there is no need to get confused, because if you are familiar with the Fourier transform properties, same steps are applicable for Laplace as well as Z transform also. Okay, so for few properties we will discuss proof. For remaining all, just I'll go with the statements itself. Okay, so Fourier transform properties proofs are important for our theoretical exam point, isn't it? So please practice Fourier transform properties thoroughly. Then easily, if you get question related to Laplace transform also, similarly you can do the steps also. Write down statement: if x1 of t is in Laplace transform pair with x1 of s, and x2 of t is in Laplace transform pair with x2 of s, then the linearity property states that. B into x2 of t Laplace transform is A into x1 of s plus B into x2 of s. Proof. So at least for 2 to 3 properties, let us see the proof also. Consider left hand side. Please write simultaneously along with me. I think everyone is maintaining the notes. If you are not writing, if you are simply logging, not listening to the class, means you will be in the trouble at the end, definitely. If not now, means maybe in third year or final year, definitely you have to read everything. So it will be like a practice. Please write everyone. Signal multiplied with kernel. Right? Very simple proof. Split the integration. Plus b into x2 of t into e power minus st dt. So already given that this is nothing but Laplace transform of x1 of t. B into x2 of t. And what about this? Hence proved, isn't it? Hence proved. Hope you have copied. Completed. Shall I go for next problem? I'm clearing the content on the board. Now, what is our next property? If I'm going fast, if you want me to repeat any concept, please unmute yourself and let me know. Otherwise, simply I'll go with my lecture. Please stop me whenever if you want me to repeat any step or if you have not copied anything. Okay. Then next, put the heading. What is the next property? Let us go with the time shifting. Time shifting property. Write on the statement. Statement. If x of t is in Laplace transform pair with x of s, then the time shifting property states that x of t minus t naught is going to be in Laplace transform pair with e power minus s t naught into x of s. Let us correlate the statement with the Fourier transform property. If x of t is in Laplace transform pair with x of s, then time shifting property states that x of t minus t naught Fourier transform was e power minus j omega t naught, isn't it? But in place of j omega, what we have here? S is there. And in place of x of omega, s is there, isn't it? So same story will be there again here. Who is that 45? Proof. Consider left hand side. Laplace transform of x of t minus t naught. What is the formula we have? What is the formula we have? X of t minus t naught. Signal. In place of signal, what I have to write? E power minus s t. 405, are you there? Diploma student. Next, what was the procedure in the proof in case of Fourier transform? Let t minus t naught equal to p. Then what about dt equal to dp, isn't it? So limits will also be same, x of p, but in place of t, what I have to write now? In place of dt also dp, x of p, e power minus st naught. Integration is with respect to p, so e power minus st naught is treated as constant. Remaining all will be inside the integration dp. Now this is of the form x of t into e power minus st dt, which is nothing but x of s. Hence proved, isn't it? Hence proved. Same proof like in case of Fourier transform. Done. This is right shifting, right? This is right shifting. Similarly, what is the other statement we have? This is the first type of shifting. Similarly, we also have if x of t plus t naught is there, what is its Laplace transform? Plus st naught into x of s. Clear? Sai Kiran? Manikanta? Satvik? Okay. Next. Shifting in S domain. Previously, the shifting was in time domain. Now shifting in S domain. Okay. In case of Fourier transform, shifting was in frequency domain, right? Same story here. So the statement you write now, if x of t is in Laplace transform pair with x of s, then the shifting in S domain property states that two cases will be there, right? Here also, e power plus at into x of t. Can anybody guess what it could be the Laplace transform for this time domain function? Can anybody guess what is the corresponding Laplace transform for these two time domain functions? X of
S by A.
S by A. Shifting, this is not scaling.
S minus S naught.
S minus A. What is the constant I have taken here? A I have taken, right? In shifting it in frequency domain or S domain, opposite sign we will get. If t minus previously, x of t minus t naught, shifting in time domain, negative exponent, whatever sign is there, e power minus st naught. If x of t plus t naught means e power plus st naught. Even in Fourier transform also same concept. Here e power minus j omega t naught. Here e power plus j omega t naught. Here also x of omega plus omega naught we will get if minus is there. If plus omega naught is there means x of omega minus omega naught we will get like that. Okay. So for the second type of shifting, what I have to write? X of s plus a. Okay. Let us see the proof now quickly. Proof. Try to prove this. So I'm taking the first case or second case, whatever you can take. Let us see the second one. Laplace transform of consider LHS. This one I'm taking. Laplace transform of left side function e power minus 8 into x of t. This is our signal to which I'm trying to find Fourier transform. Signal multiplied with kernel will change the domain. Now in place of signal, minus st dt, right? E power minus s plus a t dt. Right? Now what I have to write? This is of the form x of t into e power minus st dt. Okay? In place of s, what we have? S plus a is there. So from the definition itself, from the integration, what is this? X of s. But in place of s, what we have here? S plus a. So from the definition of Laplace transform, this integration is nothing but x of s plus a. Hence proved. Okay. Hope you have copied. And clear in the content. Next, fourth property, time reversal. Statement rewrite. If x of t is in Laplace transform pair with x of s, then the time reversal property states that x of minus t. Can anybody guess? In case of Fourier transform, x of minus t Fourier transform, what was x of minus t Fourier transform?
X of minus omega.
X of minus omega.
Similarly, here also x of minus s will be there. So we can use all these properties in deriving the Laplace transform of different types of signals. Okay. Proof. Consider LHS again. Laplace transform of x of minus t. From the definition itself. Signal. In place of signal, what we have x of minus t into e power minus st dt. So now same story again. Let minus t equal to p. Then what about dt? Minus dt. These are the limits for t variable, right? T is varying from minus infinity to plus infinity. Now in place of t, what I have to substitute? Minus p. Here also minus p equal to infinity. X of p e power minus s minus p dt. Sorry, in place of dt, what I have to write? Minus dp I have to write. Now write the limits for p variable. P limits are from plus infinity to minus infinity. X of p, x of what I have to write here? What I have to write? Minus of minus s p minus dp.
Ma'am, e power, ma'am.
Ma'am, that is e power.
Sorry, sir. Yes. This is e power. E power minus of minus s p, because this is nothing but plus sp, right? So that I'm writing minus of, in place of s again minus sp minus dt. Okay. So next continuation. Here what we can write? Minus dp is there. So we can interchange lower limit and upper limit, right? P limits are now minus infinity to plus infinity. X of p e power minus s p dt. Now tell me what is this? This is of the form integration minus infinity to infinity x of t into e power minus st dt. But in place of s, what we have? Minus s is there. So this is nothing but Laplace transform of x of p, but in place of s, we have minus s. So x of minus s we have to write. From the definition again, in place of s, we have minus s. So x of minus s. Clear? Shall I go for next property?
Yes, ma'am.
Okay. Next property, put the heading time scaling. What is the number? Fifth one. Huh? Time scaling. Time scaling property. Write down statement. If x of t is in Laplace transform pair with x of s, then the time scaling property states that x of at is going to be in Laplace transform pair with 1 by mod a, same like Fourier transform statement here. There x of omega by a is there, 1 by mod a was also there. even in Fourier transform also. Okay. Proof. Proof. There also we have done for only one case. That means when A is greater than 0. If A is greater than 0, then the statement of time scaling property is that x of at Laplace transform is 1 by plus A means plus A. 1 by mod of plus A is 1 by A only. X of A. This we have to prove now. If A is less than 0 means 1 by minus A we will get, isn't it? 1 by plus A only again. Mod of minus 2 is plus 2. Mod of 2 is also plus 2. That means whether A is greater than 0 or less than 0, x of minus 2t may be there or x of plus 2t may be there. Here, definitely we are going to get positive constant. That's why mod is given here. That is the statement. Try to prove this. So I'm taking the case first, special case when A is greater than 0. Only for this case I'm going to prove. Consider left hand side. Laplace transform of x of at. From the definition, signal multiplied with kernel x of at into e power minus st dt. Next, what we have to do next? Let at equal to some constant p, then dt equal to dp by a. Same procedure in case of Fourier transform. Limits will be same for both t and p. X of p e power minus s. In place of t, what I have to write? P by a. And in place of dt, dp by a. So 1 by a, if you take it out of the integration, x of p into e power minus s by a into p dp. Now see here, this is of the form x of t into e power minus st dt. But in place of s, we have s by a is there. So this is nothing but 1 by a into Laplace transform of the signal x of p, where p is also a time related variable, isn't it? So this is nothing but x of s by a. In place of s, we have s by a. So let us write it as 1 by a into x of s by a. Similarly, a less than 0 if you take, then also you will get plus a only here. Copied. Shall I go for next property? Yeah, Pooja, take screenshots now.
Okay, ma'am.
I'm erasing the content. Next. So next to properties, if any important proofs are not repeated in theoretical point, but still like a practice for at least for Fourier transform I'm discussing, because definitely for Fourier transform we can expect the properties and proofs, whereas problems for this Laplace transform, simple problems only, not that much of like in case of Fourier transform, because anyhow one more separate this is a separate subject itself is there for Laplace transform. There in detail it will be covered. Next property. How many minutes we have now? Time differentiation property, which is very useful in control system. Time differentiation property. Write down the statement. If x of t Laplace transform is x of s, then time differentiation property states that dx of t by dt. Even in our subject also we have problems, system problems, mainly system solving problems based on this property only. And Laplace transform, what is the one more application? Useful in solving differential equations, isn't it? So you in solving differential equations also we need this property. We use this s into x of s minus small x of 0, small x of 0, where x of t is a causal signal, where x of t is a causal signal. Okay, where x of t is a causal signal. See here, actually there are two types of Laplace transform: bilateral Laplace transform and unilateral Laplace transform. Bilateral Laplace transform means that signal will be existing both the sides, means for both positive values of time as well as for negative values of time. Unilateral Laplace transform means only one-sided, I mean only positive side we will consider in the definition of Laplace transform, that is in the integration. Actually, all the properties, whatever properties we discussed in some textbooks, the proof is explained only using these limits, 0 to infinity. That means for few properties, the signal is assumed as a causal signal. What is meant by causal signal? Which exists only right side, means right side means only for positive time values. If the signal is existing for only positive time interval, means we call that signal as a causal signal. Negative side, no amplitude, 0. So in that case, what we have to take limits? 0 to infinity only. So that type of Laplace transform is known as unilateral Laplace transform. That is the only difference. That's it. Bilateral and unilateral. Bilateral means both the limits, negative, positive. Unilateral means only 0 to infinity we will consider in the limits. Okay, this is a basic difference. So here what is the given in the statement itself, where x of t is a causal signal. Causal signal means what I have to take limits? 0 to infinity only, means it will be existing only for positive time values. Please make a note of this Laplace transform: bilateral Laplace transform, unilateral Laplace transform. Bilateral means both the limits, minus infinity to negative values as well as positive time values, signal will be existing. Unilateral means signal is a causal signal, means limits we have to take only from 0 to infinity. That's it. This is a difference between bilateral and unilateral Laplace transform. Copy this, bilateral and unilateral. So let us see the proof now. The proof is very simple in say 1 or 2 steps. The proof is. Proof. Consider, see here, this is capital X, this is small x of 0. Consider Laplace transform of dx of Laplace transform of dx of t by dt. Okay. As the signal is given as a causal signal, limits what we have to take? 0 to infinity only. In place of signal, this input signal given into kernel. Okay. So here we are going to use this formula directly. Please make a note of this. Integration of d into u of x by dx into v of x dx. What is the formula we have? U of x into v of x minus u of x into UV rule, dv of x by dx. So in shorthand, definitely we write it as integration of u dash into v equal to uv minus integration of u into v, isn't it? UV rule, uv minus integration of u into v dash. So this we have to apply here. This formula. Okay. Try to apply that. Apply that. So continuation. Laplace transform of dx of t by dt. What are the limits we have? 0 to infinity is there, right? 0 to infinity. This is x of t is like u of x and e power minus st is our v of x, isn't it? U of x into v of x means what I have to write here? X of t into e power minus st. Compare these two. Minus integration of 0 to infinity u of x. U of x means what I have to write? X of t dv of x by dx means here in place of x what we have variable t. In place of v of x what we have? E power minus st, isn't it? And this is here it is dt will be there. Here also dx. Integration is with respect to t variable. Okay. Next, substitute upper limit over here. What is e power minus infinity value? What is it? X of infinity e power minus infinity minus x of 0 e power 0 minus of 0 to infinity x of t. Now what is the differentiation of this? Minus st into e power minus st dt. Yes. Do you have any doubt? Do you want me to repeat any step? E power minus infinity is 0. 0 multiplied with anything is 0. Continuation is this. And x of 0. E power 0 value is 1 minus of minus s. Here anyhow minus s is there. Let us write it as plus s. 0 to infinity x of t e power minus st dt. Now tell me what is this? What is this?
X of s.
X of minus s.
X of minus s.
X of x.
S into x of s.
Which is nothing but minus x of 0 plus s into x of s, because this x of t is given as causal signal. Unilateral Laplace transform s into x of s. So s into x of s minus small x of 0. Hence proved. Okay. So only UV rule formula we have applied here in the proof. This property is very useful. Applications are more related to time differentiation property. Okay. Here in the content. Note. I don't know. Laplace transform of dx of t by dt. What we got? S into x of s minus x of 0. Next, Laplace transform of the square of order. D square x of differentiation of the order 2. Can anybody guess? S square into x of s minus s into x of 0 minus x dash of 0. Next, Laplace transform of order d cube x of t by dt square. Now can anybody guess? S cube into x of s minus s square into x of 0 minus s into x dash of 0 minus x double dash of 0. If all the initial conditions are 0 means these terms will be eliminated. Simply all the terms will be eliminated. If all the initial conditions means these are all our initial conditions, x dash of 0, x double dash of 0. These are all initial conditions. Okay, if all the initial conditions are 0 means only this particular single term, first term will be existing. Okay. So like this order will be continued. If the order is of 3 means x cube into x of s minus s square x of 0, partial differentiation of order 1, 0. Differentiation of order 2, 0. Like that. Okay. Next state, that also you write next statement. If all the initial conditions are, if all the initial conditions are assumed to be 0, if all the initial conditions are assumed to be 0, then if all the initial conditions are assumed to be 0, then the time differentiation property is, then the time differentiation property is that states that, anything you can write. Now tell me, d power n into x of t by dt power n. Tell me what is its Laplace transform if all the initial conditions are assumed to be 0? What is its Laplace transform? D power n into x of t by dt power n. If all the initial conditions are assumed to be 0, then what is the Laplace transform of the order small n? D power n into x of t by dt power n. What is its Laplace transform?
S power n.
S power n into x of s minus x of 0.
All the conditions are assumed to be 0 means as
S
I
power
already
n.
x of s, that's it. So this property is very, very important. This statement, if initial conditions are given, mentioned in the problem while solving differential equations or system problems, we use this formulas. If it is not given means directly we go with this. Okay. So this you have to remember, very, very useful. This one. D power n into x of t by dt power n Laplace transform is